Hello there and welcome to the calm space of LUMIVERSE NL. Perhaps it's been a long day, or perhaps you simply wish to drift beneath the rhythm of starlight. Tonight, we turn our gaze upward, into the vast ocean of the night sky, a place where silence glows, and every flicker of light carries the memory of time. Above us stretch the familiar wonders, the moon, the constellations, and the quiet pulse of distant planets. Yet beyond those familiar lights lies a deeper story, written across billions of years. Some of the stars we see have already faded, their final light still crossing the void toward us. A wisp of cloud may not be a cloud at all, but a galaxy so far away that its light began traveling before life ever touched Earth. And a streaking meteor, gone in an instant, may be no larger than a grain of sand. The night sky is both ordinary and extraordinary, the same canvas each evening and yet never the same twice. Each breath beneath it connects us to countless generations who looked upward with the same quiet wonder. From the deserts of the ancients to the observatories of today, we have always sought patterns among these lights, seeking meaning, guidance, or peace. In those moments, we are not just observers. We are part of the same story, written in starlight and silence. As your mind begins to soften and your breath slows, let your thoughts wander upward. Imagine standing beneath a sky untouched by city lights, where the Milky Way unfurls like a silver river and the air itself hums with quiet. Out there, every glimmer is a sun, every faint glow a world unseen. And yet, here on Earth, the same light finds your eyes, crossing the gulf of space, whispering that you belong to something infinite. So tonight, let go. Let the night sky carry you gently, the way it has carried every dreamer before you. If these quiet journeys bring you peace, share a thought, or simply rest a while with us here in LUMIVERSE NL, where science becomes serenity and knowledge becomes calm. Because sometimes the best way to understand the universe is to fall asleep beneath it. Every star you see with your eyes tonight is a messenger from the past. When light leaves a star, it begins a journey through time, racing across the vacuum of space for years, centuries, even millennia, before it ever touches our world. So when you look up, you're not seeing the universe as it is now. You're seeing what it once was. That bright white spark may have begun shining long before the first humans lit a fire. A soft glow near the horizon could be light that started traveling when mammoths still roamed the earth. And a faint red star, nearly invisible, may have already died, its final light only now arriving, long after the star itself has vanished. The night sky is not a portrait of the present, but a vast living memory of everything that has ever burned. Light travels at nearly 300,000 kilometers per second, faster than anything we can imagine. Yet the distances between stars are so immense that even at that speed, their glow takes lifetimes to reach us. Our nearest stellar neighbor, Proxima Centauri, lies more than 4 years away by light alone. Most others are hundreds or thousands of light years distant. This means that when you gaze at the sky, you are peering through a window into the deep past, into eras older than civilization itself. In a way, starlight is time made visible. Each shimmer above is an echo, a fragment of the cosmos whispering its story across impossible distances. Some of the light began its voyage when Earth was still a world of oceans and single-celled life. Other beams may outlast us, continuing their endless flight long after humanity is gone. To see the stars is to see memory itself, luminous, silent, and patient. Astronomers call this the look-back effect. The farther we look, the further back in time we see. Telescopes become time machines, catching light that began its journey billions of years ago. Through them, we can witness galaxies being born, stars igniting for the first time, and the faint afterglow of creation itself. Every photon that reaches us is a survivor, proof that the universe has been speaking since the beginning, and we are finally listening. So as you rest tonight, remember, every sparkle above you is not just a point of light. It's a heartbeat from history, crossing the void to find you. And in its quiet arrival lies the oldest truth of all, that even in darkness, light always finds a way. If you find comfort in this calm exploration of time and stars, consider leaving a quiet thought or subscribing to LUMIVERSE NL. So together, we can keep wandering through the gentle rhythm of the universe. For as long as we've watched the heavens, one star has seemed steadfast. Polaris, the North Star. It hangs almost perfectly above Earth's northern axis, marking true north and guiding travelers across centuries. To sailors, explorers, and wanderers of old, it was more than a point of light. It was certainty, a fixed beacon in a moving world. But even Polaris is not eternal. The Earth itself wobbles gently as it spins, like a slow-turning top. This motion, called precession, shifts the position of the poles over thousands of years. As the axis tilts and traces a small circle in the sky, the star we call North slowly changes. Polaris hasn't always held this place of honor, and one day it will move aside for another. In the time of ancient Egypt, the North Star was a different one. Thuban, shining faintly in the constellation Draco. 12,000 years from now, it will be Vega, brilliant and blue that claims the crown. Imagine standing beneath that future sky. When Vega reigns where Polaris now gleams, the same Earth will spin beneath it, yet every familiar pattern will have shifted. It's a quiet reminder that nothing, not even the stars we trust most, stays still forever. All things, given time, are drawn into motion, even the compass points of the cosmos. This slow celestial dance has guided human history in ways we rarely consider. Temples, pyramids, and monuments were built to align with stars that no longer hold the same positions. The heavens that once crowned ancient cities have since drifted. What those builders called North is now slightly different, shifted by the planet's endless wobble. The universe writes its stories slowly, so slowly that we can only glimpse them across ages. So when you find Polaris tonight, let it remind you not of permanence, but of movement. Every steady light is part of a greater cycle. Every fixed point only appears so because we move too. The North Star's calm glow is an illusion of time, a reflection of the same impermanence that shapes everything we know. Somewhere, far in the future, another traveler will look up at another sky. They will follow a different star, trace different constellations, and feel the same quiet wonder you feel now. And in that moment, cross millennia, you and they will share the same truth, that to look upward is to see motion, patience, and change written in light. Long before satellites and digital maps, humanity's first compass was the sky. In every corner of the ancient world, long before compasses or clocks, people looked upward for direction. They memorized the slow rise and fall of constellations, watching how each pattern appeared at certain times of year, how each bright star could point the way home. For the first travelers, navigation was not a science. It was a song, a rhythm between Earth and the heavens, repeated across generations. In the Pacific, Polynesian wayfinders crossed thousands of miles of open ocean guided only by the stars. They read the night sky as if it were a living map. Orion rising in the east, the Southern Cross low on the horizon, the path of Venus gleaming before dawn. Each star had a name, a story, and a direction. Together, those stories formed invisible highways stretching across the sea. To the Polynesians, navigation was a sacred art passed through memory and ritual, a conversation between the ocean and the sky. By knowing where a constellation rose and where it set, they could chart their course with astonishing accuracy, steering wooden canoes across vast blue deserts. The same was true in deserts of sand instead of water. Nomads of Arabia and North Africa traveled by night, following the steady gleam of Polaris or the alignment of bright stars like Sirius and Arcturus. They measured the height of those stars above the horizon to judge latitude, just as sailors measured the same over the sea. The sky, unchanging to the naked eye, became the world's first GPS, a universal map drawn in light. In Greece, travelers memorized the paths of the constellations. The philosopher Thales taught that navigation could be mastered by studying Ursa Minor, the little bear, whose tail points toward Polaris. For the Vikings, centuries later, the stars remained constant companions. When clouds hid the heavens, they watched the shimmer of sunlight on crystals of Icelandic spar, a natural compass that revealed the sun's hidden position even at twilight. By combining that faint glimmer with their memory of star patterns, they could sail from Norway to Greenland, then to the far edges of North America, guided by light that had traveled across both time and sea. Every culture built its own sky map. The Maya tracked the cycles of Venus to plan planting and harvests. In China, the imperial astronomers recorded the heavens with precision unmatched for centuries, marking eclipses, comets, and the steady path of the stars. In Africa, Aboriginal and Dogon traditions told stories of cosmic rivers and ancestral travelers crossing the Milky Way. To them, constellations weren't just guides. They were ancestors, spirits, and teachers watching from above. These traditions carried something deeper than astronomy. They revealed that before we studied the stars, we listened to them. Each flicker became part of human memory, woven into myths, rituals, and songs so they could never be forgotten. The sky was our shared language, our collective map of belonging. Even now, in the age of satellites and GPS, that connection endures. A pilot crossing an ocean may no longer rely on starlight, but the same constellations still mark their way. A child in a city might not see the Milky Way, but the idea of the North Star still means home. And in remote places, where the darkness remains true, modern navigators still practice the old ways, charting courses by hand, watching Orion's belt rise or the arc of the Big Dipper turn toward dawn. When you stand beneath the night sky, you are part of the same lineage, a quiet continuity stretching across 10,000 years of human curiosity. The same constellations that guided caravans through deserts and canoes across oceans still shine above you now, unchanged in their rhythm, constant in their slow dance through time. The stars were our first teachers, our first maps, our first sense of direction. They taught us to move forward by looking upward, to find our way not just across the earth, but within ourselves. So if you ever feel lost, look to the night sky. Its wisdom is older than any chart or compass. Each point of light is a reminder that every traveler before you once looked here too, trusting these same eternal flames to lead them home. Because no matter how far we go, the stars have always known the way back. On a clear, moonless night, far from cities and noise, the Milky Way stretches across the sky like a river made of light. It arches from horizon to horizon, a faint, misty glow that seems almost alive, flowing silently above the world. For thousands of years, people have looked up at that luminous band and wondered what it was. A road of spirits, a path of ancestors, a celestial river dividing the heavens. Every culture gave it a name, and every name carried awe. Today, we know what the ancients could only dream of. That ghostly ribbon is our home, the galaxy we live in, seen from within. The Milky Way is not just a sight in the sky. It is the very structure that holds our solar system among hundreds of billions of others. When you look at that hazy light, you are peering edge-on through the flat disk of our galaxy. We are inside the swirl itself, looking along the lanes of its arms. If you could step outside and see it from afar, it would appear as a vast spiral, a wheel of stars, gas and dust, turning slowly through the darkness of space. Imagine yourself standing on the edge of one of those arms, looking inward, toward the glowing core where stars crowd together by the millions, shining with ancient light. The Milky Way measures roughly 100,000 light-years across, a span so immense that light itself takes 100,000 years to travel from one side to the other. Within that space, astronomers estimate there are between 200 and 400 billion stars. And around those stars, billions of planets, worlds of ice, rock, and gas, circling suns we will never see. Our own sun is just one modest star among them. It lies about halfway between the galactic center and the outer edge, tucked quietly into a minor arm called Orion's spur. From here we look outward through the disk and see the combined glow of uncountable stars merging into that soft, milky haze. Every shimmer you see is a star system. Every faint blur, a cluster of suns, or perhaps the glowing gas of a nebula where new stars are born. You could stare at a single patch of the Milky Way and see more than 1,000 distant suns within it. It's not a single object. It's a congregation of billions, woven together by gravity and time. The light you see from the Milky Way has traveled across vast distances. Some of it began its journey when early humans still painted caves. Some of it when Earth's continents were still drifting toward their modern shape. The Milky Way is both a photograph and a memory, showing us the galaxy not as it is now, but as it was thousands of years ago. In every glimmer is a fragment of history, the slow pulse of a living system too vast for us to ever fully grasp. To ancient civilizations, this site was sacred. The Greeks called it Galaxies Kyklos, the Milky Circle, born from mythic tales of spilled divine light. In China, it was the Silver River, where lovers separated by the gods could meet only once a year, when the magpies formed a bridge of stars. The Mayans saw it as a cosmic tree connecting the heavens and the underworld. To the Aboriginal peoples of Australia, it was the emu in the sky, its dark lanes of dust forming the shape of a great bird across the stars. Different worlds, different stories, yet all gazing at the same flowing band of light. Modern science has revealed the truth behind the beauty, but it has not taken away the wonder. We now know that within the Milky Way are not only stars, but also giant clouds of gas and dark matter, the invisible scaffolding that gives the galaxy its shape. The spiral arms rotate around a central bulge, and at its very heart lies a supermassive black hole. Sagittarius A, the silent anchor of our galaxy. Every star, including our sun, orbits this unseen center, completing one full revolution, roughly every 230 million years. It means that the last time our solar system was in the same position within the Milky Way, dinosaurs roamed the Earth. We are travelers not just through time, but through the galaxy itself, carried slowly along the current of a cosmic river. And that river never stops moving. It turns, ripples, and breathes with motion. Its stars drifting like sparks in an endless tide. Even now, the Milky Way is reaching outward, tugged by gravity toward our nearest galactic neighbor, Andromeda. In about 4 billion years, the two will meet and merge, forming one immense, luminous world of stars. From some far future planet, our descendants may look upward and see not one river of light, but two, intertwined and shining, a testament to the universe's quiet power of creation. So tonight, when you see that faint band stretching across the darkness, remember what it truly is. It is home, a spiral of suns and stories, of time and silence. A living river of light flowing endlessly through the void, carrying us with it every moment of every night. And though we cannot see its full shape from where we stand, we are part of it. Every heartbeat, every breath, Every dream unfolds within its arms. The Milky Way is not something we look at. It is something we belong to. When you step outside on a cloudless night and lift your eyes toward the Milky Way, you might feel as though the stars stretch forever. The sky seems infinite, a boundless ocean of light. Yet what you are seeing, all those thousands of shimmering points, represents only the tiniest fraction of what truly exists. Under the best conditions, far from cities and light, the unaided human eye can see about 6,000 stars across the entire sky. That number sounds vast until you compare it to the true population of our galaxy. Hundreds of billions of suns, 6,000 against hundreds of billions. It's like standing on a beach, holding a single handful of sand, and imagining the rest of the shore. Every speck of starlight you see belongs to our own Milky Way. The galaxies beyond, Andromeda, Triangulum, and countless others, are too distant for their individual stars to be seen. Instead, they blur together into faint, ghostly glows that drift across the black. So when you look upward and feel surrounded by stars, remember that you are seeing only your neighborhood, a single island of light in an endless cosmic archipelago. Astronomers use telescopes to pierce the darkness and count what we cannot. Through these instruments, the night multiplies. Where our eyes see a dozen stars, a telescope reveals thousands. And in the deepest images ever taken, such as the Hubble Deep Field, every dot, every single flicker of light, is an entire galaxy containing billions of stars of its own. The vastness of the universe is not just a matter of size, but of scale upon scale upon scale, each layer unfolding into another without end. Our sun, bright and commanding in our sky, is merely average, a yellow dwarf among a sea of larger and smaller suns. Many stars are far more luminous, blue giants blazing with fierce energy, thousands of times brighter than our own. Others are smaller, dimmer, cooler. Red dwarfs that burn slowly for trillions of years, and between them exist endless variations. White dwarfs, binary pairs, variable stars that pulse like cosmic hearts. Every one of them part of the same grand orchestra of light. If you could somehow travel between the stars, hopping from one system to another, you would see how vast the spaces truly are. Even the nearest star, Proxima Centauri, lies more than 4 light-years away. That's 40 trillion kilometers of emptiness. A gulf so large that it would take our fastest spacecraft over 70,000 years to reach it. In the dark, between those suns lies more than just distance. It is a silence deeper than anything we can experience on Earth. The stars may look close, but each is alone, suspended in solitude, separated by seas of nothingness. And yet, that emptiness is filled with motion. Our solar system orbits the galactic center at nearly 800,000 kilometers per hour. The stars you see overhead are not fixed, but moving too, each tracing its own slow path through the Milky Way. Over millions of years, constellations will twist and change, Orion's belt bending, the Big Dipper losing its shape, until the sky itself becomes unrecognizable. It's a quiet reminder that the cosmos is never still. The heavens move even when we cannot see them move. When ancient stargazers looked up thousands of years ago, they saw many of the same stars we see today. But some of those stars are already gone, their light still journeying toward us. To them, the night sky was eternal. To us, it's a time machine. The glow of every star is the echo of an event that has already happened, a story that ended long ago. And yet, in that echo, there is continuity, a bridge between what was and what is, between life and memory. We are bound to these lights in ways both physical and poetic. The elements in our bodies, the carbon in our cells, the calcium in our bones, the iron in our blood, were all forged inside stars that lived and died billions of years ago. When those stars exploded, they scattered their ashes into space, seeding future systems. including ours. So when you gaze at the night sky, you are not just looking outward. You are looking back into the very matter that created you. Every star, no matter how distant, is a reflection of something within us, a shared ancestry written in atoms and flame. The thought can feel overwhelming, that we are so small within such enormity. But perhaps it's the opposite. Perhaps the wonder is not in how small we are, but in how connected we remain. The same gravity that holds galaxies together holds us to the ground. The same physics that shape the birth of stars shape the breath in your lungs. The universe is not out there. It's within and around us, unfolding through time like a quiet, endless tide. So when you look up tonight, let the scale humble you, not into fear, but into calm. The night sky reminds us that everything is temporary, yet nothing is lost. Light travels, stories continue, and even the smallest spark carries across eternity. We are part of that flow, each of us a fleeting shimmer in a sea of billions, yet luminous all the same. The stars do not demand our understanding. They simply ask that we notice. And in noticing, we remember who we are, the children of light, watching the ancient glow of our own beginnings. Every so often, as you gaze into the dark, a brief flash cuts across the sky, swift, bright, and gone in an instant. We call it a shooting star, though it is not a star at all. It is a grain of cosmic dust, smaller than a pebble, burning as it collides with the thin air of Earth's upper atmosphere. For a moment, that speck becomes fire, a spark that lights the heavens before fading into memory. Each shooting star begins far from Earth, drifting silently through the solar system. Some are fragments of comets, icy wanderers that shed trails of dust as they swing close to the sun. Others are tiny remnants of asteroids, broken apart by time and collision. When Earth's orbit crosses one of these dusty trails, countless particles plunge through our sky, each one flaring for a heartbeat before vanishing. To the eye, they seem magical, unpredictable, and alive, but their paths are written in the steady rhythm of the cosmos. Most of these fragments are no larger than a grain of sand, yet they enter the atmosphere at incredible speeds, tens of thousands of kilometers per hour, compressing the air before them so violently that it heats to incandescence. For a second or two, they glow brighter than any star, leaving luminous trails that fade like ghostly brush strokes across the night. The meteor itself rarely survives the journey. It disintegrates long before it ever reaches the ground. What we see is not the object itself, but the story of its ending. A final burst of light in surrender to gravity and fire. Sometimes these trails appear not alone, but in showers. When Earth passes through the dust stream left behind by a comet's orbit. Each year, the Perseids in August, the Geminids in December, and the Leonids in November remind us of this recurring cosmic choreography. Their names come from the constellations they seem to emerge from, as though the stars themselves were shedding sparks. During these nights, the sky comes alive. Dozens, even hundreds of meteors streaking every hour, a storm of silent brilliance. In the stillness of a dark night, you can lie back and watch them fall, one after another, a celestial rain that connects our small world to the endless paths of space. Ancient people saw these lights as messages from the gods, omens of change or renewal. In some cultures, a falling star meant a soul ascending to the heavens. In others, a wish waiting to be made. To the Maori of New Zealand, meteors were the sparks of ancestral fires. In Greece and Rome, they were thought to mark divine attention, a sign that the gods were watching. Even now, in the quiet of modern nights, we still pause when we see one. For all our knowledge, something inside us still whispers to make a wish. Science too finds wonder in these fleeting fires. Astronomers track meteor showers to trace the orbits of comets long vanished. By studying the dust that burns in our sky, they can learn about the birth of the solar system itself. Each particle is ancient, older than Earth, a fragment of the original cloud of rock and ice that formed our planets. When it burns in our atmosphere, it carries with it the chemistry of creation, briefly writing the story of the early solar system in streaks of light. On rare occasions, a larger fragment survives the plunge. It slows, cools, and falls to the ground as a meteorite, a piece of the cosmos you can hold in your hand. Some of these stones are billions of years old, formed before Earth itself. Their surfaces are etched with patterns from their fiery descent, and their metals whisper of places we will never see. Asteroids shattered, worlds unborn, stars long gone. To hold one is to feel the weight of time, condensed into a fragment of space dust. But for most of us, meteors remain ephemeral, visible for only a second, and yet unforgettable. They appear without warning, vanish without trace, and leave behind only silence. In that silence lies something profound, the awareness of impermanence. Every streak reminds us how fragile light can be, how beauty often exists only in its passing. Perhaps that is why meteor showers draw us out at midnight, not to see the sky itself, but to feel time move through it. Some nights, the sky is quiet. Others, it's alive with motion, hundreds of glowing lines crossing the heavens, each one a farewell. And if you're patient, lying beneath that cosmic rain, you'll begin to sense something deeper. Not chaos, but rhythm. Not destruction, but renewal. Because every grain of dust that burns away becomes part of Earth, absorbed into the air we breathe, the soil beneath our feet. The universe falls upon us constantly, gently, endlessly, a soft shower of stars that connects heaven and earth. So when you see a meteor tonight, take a moment to look longer. Watch it fade. Watch it dissolve into the dark. That small spark has traveled across millions of kilometers to reach your eyes. And in its dying, it leaves behind a trace of wonder. It is the universe reminding you that even the briefest light can touch eternity. There are places on Earth where the night sky still looks the way it did thousands of years ago. Pure, untouched, and infinite. Far from cities, deep in deserts or atop mountain peaks, the darkness feels alive. When you stand beneath such a sky, the Milky Way isn't just a faint haze. It's a river of light so bright it casts shadows on the ground. Every horizon glows with stars, and the silence feels heavier than air. In those moments, you realize how rare true darkness has become. Most of us live under skies washed pale by human light. Street lamps, billboards, and endless windows glowing through the night have turned the heavens into a dim reflection of what they once were. The stars haven't vanished. We've simply drowned them in our own glow. This invisible fog of brightness is called light pollution, and it has spread across the world faster than almost any other form of pollution. From orbit, Earth gleams like a luminous web. Cities burning against the dark. Oceans edged with gold. Beautiful, yes, but costly. Because with each watt we pour into the sky, we lose a little more of the universe above. Astronomers have measured how quickly this change has happened. In just a few generations, the average brightness of the night sky has increased more than tenfold. Children born in cities today may never see the Milky Way at all. To them, the night is a handful of bright dots and the occasional passing plane. Entire constellations, Orion's belt, the Pleiades, the Southern Cross, fade into invisibility behind the city haze. It's as if humanity has closed its own window to the cosmos, one light bulb at a time. But there are still sanctuaries of darkness, fragile, precious refuges where the stars return to their full brilliance. In remote corners of the world, conservationists have begun protecting dark sky reserves, vast areas shielded from artificial light, Here, telescopes sweep through pristine air, capturing the faint whispers of distant galaxies. Here, visitors rediscover what it means to see the sky as our ancestors once did. Standing beneath that depth of stars, you can feel the weight of the cosmos pressing down, not in fear, but in reverence. The sheer abundance of light above silences every thought. The universe, unveiled, feels almost close enough to touch. To witness such a sky is to understand how deeply we belong to it. For most of human history, night was not a void to be feared, but a canvas for stories and wonder. It guided migrations, inspired myths, and gave birth to astronomy itself. People read the stars as others might read books, tracing their shapes, naming their heroes, mapping their gods. The sky gave us both direction and imagination. Now, in the glare of modern life, we risk losing that quiet dialogue with the heavens. The cost is not only scientific but spiritual. Without the night sky, we forget how vast reality truly is. We lose the sense of scale that once humbled and comforted us. When the stars fade, so too does our awareness of mystery, replaced by the illusion that we've already seen everything worth seeing. Yet above every city, the stars remain. They're waiting, hidden behind the haze, patient as time itself. All we have to do is let the darkness return. Some communities are doing just that. Small towns in the American Southwest, the deserts of Chile, and the high plateaus of New Zealand have adopted dark sky ordinances, shielding lights, dimming streets, and turning off unnecessary illumination after midnight. The result is astonishing. Within weeks, the stars reappear, the Milky Way unfurls again, and people rediscover what it means to look upward. Astronomers call this reclaiming the sky. But for many, it feels more like remembering something sacred that was never truly lost. To stand beneath a dark sky is to feel both ancient and new. You see the same constellations that guided nomads across deserts and sailors across oceans. You breathe the same night air that carried the myths of every civilization before ours. And as your eyes adjust, more and more stars appear, faint at first, then brighter, until the heavens themselves seem to awaken. You begin to notice colors: blue, gold, red, each hue revealing a different kind of star. The band of the Milky Way glows like smoke. Clusters sparkle like dust caught in light. It is almost too much to take in, too much to hold. There is a moment just before dawn when the stars begin to fade and the eastern sky turns pale. It feels like the world exhaling, the slow return of light, both natural and man-made. But in that final hour of darkness, before morning claims the sky, you understand something essential. The night does not disappear, it only retreats. And every time we allow true night to return, the universe comes back with it, vast, silent, patient, and full of light. So tonight, if you can, step outside and switch off the lights for a while. Let your eyes adjust. Let the stars re-emerge from behind the veil. Because somewhere, out there in that infinity, countless worlds are shining, waiting to be seen. And all it takes to find them is darkness. When we look up at the night sky, the constellations seem timeless. Orion's belt, the Big Dipper, Cassiopeia, the Southern Cross. Their shapes are so familiar that we imagine them frozen forever, as if the stars themselves have not moved since the dawn of civilization. But the truth is far more fluid. The sky is not still. The constellations we know are snapshots, temporary arrangements in a cosmic dance that unfolds over millennia. Each star you see drifts through the galaxy with its own velocity and its own orbit around the galactic center. From our perspective on Earth, these motions are too subtle to notice in a single lifetime. But over tens of thousands of years, the patterns begin to warp. Lines stretch, angles tilt, and the constellations that guided our ancestors slowly dissolve into new shapes. Astronomers call this slow shift proper motion, the gradual change in a star's position against the background of more distant stars. It is the sky's way of breathing, invisible to our eyes but continuous and unstoppable. Consider Orion, the mighty hunter, one of the most recognizable constellations in the heavens. His belt, the straight line of 3 stars, will not remain aligned forever. Each of those stars is moving at a slightly different speed and direction. In about 100,000 years, Orion will look nothing like the figure we know today. The hunter will fade, his bow broken, his belt undone. Ursa Major, home to the Big Dipper, will also distort. The ladle's handle will twist as some stars race ahead and others lag behind, until the familiar dipper becomes an unrecognizable scatter of light. To us, these changes feel imperceptible. The human lifespan is too brief to witness the sky's slow transformations. But astronomers, with precise measurements and time, can project the heavens forward or backward across millennia. With simulation, they can reconstruct what the night looked like to ancient people, or what it will look like to future ones. The constellations of 50,000 years from now will be strange to our eyes. Orion will have stretched thin, and the Big Dipper will resemble a bent hook. Cassiopeia's elegant W will begin to flatten, while Scorpio's long curve will fade into a looser arc of dimmer stars. Even the zodiac, the ancient wheel of constellations that tracks the sun's yearly path, will subtly shift, its boundaries rewritten by time. This cosmic drift reveals something humbling. Nothing in the universe is fixed. Every star, every system, every galaxy is in motion. The universe is not a static picture, but a film, an endless unfolding story where we happen to live in a single frame. When we draw lines between the stars and call them shapes, we're connecting moments, not objects. Those patterns exist only from our perspective, and only for a short while in cosmic time. The hunter, the bear, the swan, they are our projections, brief alignments in a ceaseless dance of motion and light. In ancient times, people used these constellations not only for navigation, but as mirrors of their world. Orion became the hunter because humans hunted. The Pleiades were sisters because family was sacred. The scorpion and the lion fought across the sky because those symbols live deeply in our stories. Each pattern was a reflection of the human imagination imposed upon the stars. But the stars, indifferent and patient, move on, reshaping the very canvas we use to tell those tales. Our myths drift with them, carried forward by memory even as the heavens themselves change form. If you could watch the sky in fast motion, not over a single night, but across thousands of years, you would see constellations melt and reform, as if the stars were alive. The Big Dipper would twist into a long curve, while Orion's stars drift apart like embers scattering in the wind. New shapes would emerge, ones no human has named. The patterns of the future will belong to civilizations yet to exist. People who will look up and imagine their own stories in those unfamiliar skies. Perhaps they too will see hunters, bears, or dragons. Or perhaps something entirely new. Symbols for worlds and ideas we cannot yet conceive. Even the pole star, our fixed point of navigation, changes with time. As the Earth wobbles slowly on its axis, a motion called precession, the North Star shifts. Thuban once guided the ancient Egyptians. Polaris guides us today. Vega will take its place in another 12,000 years. The heavens themselves are written in motion, their constancy only an illusion born of human brevity. Our maps, our myths, our calendars, all are temporary sketches upon an ever-shifting sea. And yet, there is beauty in this impermanence. The stars remind us that change does not erase meaning. It renews it. The constellations that guided our ancestors may fade, but their stories endure, carried forward in words, art, and memory. And when the future sky transforms, humanity will create again, drawing new shapes, finding new meaning in the same eternal light. Because even when the patterns change, the wonder remains. So the next time you look up at Orion or trace the curve of the Big Dipper, remember that you are witnessing something fleeting, a moment in the universe's long, slow dance. You and the stars are moving together through the galaxy, sharing this one configuration of light before it changes forever. The constellations are not fixed pictures, but living arrangements, shifting reminders that the only constant in the cosmos is change itself. If you've ever traveled far south, beyond the equator where the seasons reverse and familiar constellations fade, you know how strange the sky can feel. The Big Dipper disappears completely, and Polaris, the North Star, sinks below the horizon, gone from sight. In their place, new constellations rise, bright and unfamiliar, stars that northern eyes have never seen. It is like stepping into another world, one where the map of the heavens has been rewritten. For travelers of the ancient world, this realization was both thrilling and unsettling. To venture far enough south that the known sky vanished was to step beyond the boundaries of memory and myth. New patterns appeared, strange geometries of light, brighter and closer together than anything seen before. Among them, one stood out more than any other: the Southern Cross. The Southern Cross, or Crux, is small but brilliant, a compact constellation of 4 main stars forming the shape of a tilted cross. For centuries, it has guided navigators in the southern hemisphere the way Polaris has guided those in the north. Its long axis points directly toward the south celestial pole, an invisible point around which the southern stars appear to turn. Early explorers sailing into the unknown seas of the southern oceans used Crux as their compass, orienting themselves beneath a sky that seemed reversed. For them, the cross of stars was both symbol and salvation, proof that even when the heavens change, they still provide direction. Nearby, 2 bright stars, Alpha and Beta Centauri, mark the way to the Southern Cross. They gleam like twin beacons, leading the eye toward Crux's radiant arms. Beyond them lies something even more extraordinary: 2 faint, cloud-like smudges visible to the naked eye. These are the Magellanic Clouds, dwarf galaxies orbiting our own Milky Way. To observers in the southern hemisphere, they look like soft patches of light, floating near the edge of vision. But through a telescope, they reveal themselves as entire galaxies filled with stars, clusters, and nebulae, bustling miniature worlds of their own. The larger of the 2, the large Magellanic Cloud, hosts one of the most spectacular stellar nurseries known, the Tarantula Nebula. Here, immense clouds of gas and dust glow with fierce color, illuminated by the birth of massive young stars. The region is so active that it produces supernovae more frequently than almost anywhere else nearby. To witness it through a telescope is to look directly into the heart of creation, a place where the universe is still busy making itself. The smaller of the 2, the small Magellanic Cloud, is quieter, yet no less beautiful. Its pale haze peppered with ancient clusters that have survived for billions of years. Together, these 2 galaxies drift like companions around the Milky Way, bound by gravity in a slow celestial dance. For those who live in the southern hemisphere, these sights are part of everyday life. The Southern Cross hangs high above the horizon, turning gently through the night, while the Magellanic Clouds hover nearby. Reminders that even our galaxy has neighbors. But for northern observers, these wonders are invisible, hidden forever below the line of the equator. It is one of the universe's quiet lessons, that perspective changes everything. Half of the world looks up and sees one version of the sky. The other half sees another. Both are true, both beautiful, yet neither complete on its own. Throughout history, cultures of the South have woven their own myths into these constellations. The indigenous Australians saw in the dark lanes of the Milky Way not shapes made of stars, but shapes made of shadow. The emu in the sky, stretching across the heavens. The dark clouds formed its body. The bright Southern Cross marked its head. In their stories, the emu was a cosmic being, a reminder of life, fertility, and balance. To the Maori of Aotearoa, the Southern Cross represented an anchor, connecting Earth to the spirit world. For the Inca, it was the chakana, the stairway between realms, linking the physical and the divine. The southern constellations were mapped and named by explorers and astronomers only a few centuries ago. Constellations like Dorado, Tucana, and Volans named for golden fish, toucans, and flying creatures of the seas. They filled the blank spaces of the sky left unseen by the civilizations of the north. Where the Greeks imagined heroes and gods, the southern sky spoke in new forms: animals, instruments, celestial rivers. It was as though the universe itself had painted two halves of a single story, one visible from each side of the Earth. Today, when astronomers chart the heavens, they see it as a whole, the two hemispheres stitched together into one great sphere of light. But for those who have stood beneath both skies, the difference is profound. To see Orion's belt rise above the horizon in the north and then vanish forever as you cross southward is to feel the planet's curvature in your bones. You begin to understand that the Earth is not just a world, but a window. One that frames the cosmos differently, depending on where you stand. The night sky above the southern hemisphere offers a sense of intimacy, a closeness to the Milky Way's heart. Its stars seem denser, its colors deeper. It's as if you've stepped closer to the source of light itself. From these latitudes, you can trace the great bulge of the galaxy, glowing golden near the constellation Sagittarius. Here, the Milky Way isn't just a ribbon across the sky. It's a full arc of brilliance, a storm of stars sweeping overhead. So whether you stand beneath the Northern Lights or the Southern Cross, whether you follow Polaris or Crux, you are part of the same celestial sphere. One Earth, one sky, seen from two perspectives. The constellations change, but the wonder remains constant. The stars above each hemisphere may differ, yet the feeling they inspire, that quiet recognition of belonging to something vast and luminous, is the same everywhere. The sky, like the Earth itself, reminds us that perspective is everything. Move a little, and the heavens rearrange. Look differently, and the unknown becomes visible. And through it all, the stars continue their eternal motion, shining not for one side or the other, but for all who lift their eyes to see. Among all the faint smudges and glittering lights that fill the night sky, one holds a special place: the Andromeda Galaxy. It appears small and ghostly to the naked eye, a soft blur just beyond the constellation Cassiopeia. To most people, it seems like nothing more than a wisp of cloud or a trick of the atmosphere. But what you are really seeing is something extraordinary. Another galaxy, immense and alive, shining across more than 2 million years of distance. The Andromeda Galaxy, also known as M31, is our nearest galactic neighbor. A spiral much like our own Milky Way, but larger and more luminous. It contains perhaps 1 trillion stars, stretching over 200,000 light-years from edge to edge. Its faint glow that reaches your eyes tonight began its journey long before humans existed, when Earth was home only to early ancestors still learning to walk upright. That light has been traveling across intergalactic space ever since, passing through the dark between galaxies to arrive here, now, in this very moment, to meet your gaze, to realize that you can step outside, look upward, and see another galaxy with nothing but your own eyes is one of astronomy's quietest miracles. No telescope, no special equipment, just darkness, patience, and a clear night. You are not simply observing a point of light, you are witnessing the combined radiance of a trillion suns, all blended together into a single distant shimmer. Each of those stars could have its own worlds, its own moons, its own histories unfolding unseen. And yet all we can perceive from here is that gentle haze, a whisper from across eternity. The scale of it is almost beyond comprehension. If the Milky Way were a single marble, Andromeda would be another marble about 25 centimeters away, close enough to sense, but far enough that it feels unreachable. Between us lies a vast gulf of empty space, scattered with a few wandering stars and thin clouds of hydrogen gas. And yet, gravity is slowly drawing the two galaxies together. They are approaching one another at about 110 kilometers per second, fast enough that, in roughly 4 billion years, they will meet and merge. When that happens, the skies of the far future will transform. From Earth, or whatever remains of it, Andromeda will grow larger and brighter with each passing million years. Eventually, it will dominate the heavens, filling the night with glowing arcs of stars. As the two galaxies intertwine, their spiral arms will stretch and twist like cosmic ribbons, triggering vast bursts of star formation. The collision will not be a violent crash, as the stars themselves are too far apart to collide directly. Instead, their combined gravity will weave them into one immense elliptical galaxy, a new creation born from motion and time. Astronomers already have a name for that future union: Milkomeda, or the Milky Andromeda Galaxy. In that far-off era, our descendants, if they exist, will look up at a sky utterly different from ours. The familiar constellations will have long since unraveled. But in their place will shine a magnificent fusion of light. The cosmic river of the Milky Way will be gone, replaced by a glowing halo spanning the heavens. It will be a view of completion. Two galaxies, once separate, now united in a dance that took billions of years to unfold. But tonight, Andromeda is still distant, still mysterious, still serene. Through a telescope, its spiral arms reveal themselves, wound gracefully around a bright core. Clusters of young blue stars sparkle along its edges. Ancient globular clusters orbit like tiny satellites, each holding hundreds of thousands of suns. Dust lanes trace dark streaks through the glow, sculpting patterns that mirror our own galactic structure. It is in many ways a reflection of the Milky Way, a cosmic twin, showing us what we are from the outside. The ancients saw it too. Long before the word galaxy even existed, in 964 CE, the Persian astronomer Abd al-Rahman al-Sufi described it as a small cloud in his Book of Fixed Stars. Centuries later, in the early 20th century, astronomers finally proved what it truly was: a separate island universe beyond our own. That revelation changed everything. Until then, humanity believed the Milky Way was the entire cosmos. Andromeda expanded that vision overnight, showing us that we are not the center of creation, but just one spiral among billions adrift in the dark. It's humbling to think that light can carry such a message across millions of years, that photons born from distant suns can travel through emptiness, pass through time itself, and end their journey inside our eyes. Every glimmer from Andromeda is a record of the past, proof that existence echoes far beyond our brief lives. When you see that faint patch of silver above the horizon, you are touching the ancient light of another galaxy, a bridge between two worlds that may never meet, yet remain bound by the same universal laws. The Andromeda Galaxy is not just a sight, it's a reminder that the cosmos is full of other homes, other histories, other lights that will never go dark. And even across millions of light years, we are still connected, not by distance, but by the quiet fact that we are part of the same unfolding story. That the light from Andromeda and the light from our sun both began as the same thing, the universe remembering itself through fire. So the next time you find yourself beneath a dark sky, look for that faint blur in the direction of Perseus and Cassiopeia. It might not seem like much at first, just a whisper, a breath of silver, but know that you are seeing a galaxy larger than your own, older than humanity, and destined to one day meet us in a slow and graceful embrace. It is the most distant thing your eyes will ever see unaided. And yet, in its quiet way, it reminds you that nothing in the universe is ever truly far away. Every star you see in the night sky is a story, a beginning, a middle, and eventually an ending. Stars are not eternal. They are born, they live, and they die, just as all living things do. Their lives simply unfold on scales of time so immense that to us, they seem timeless. But even the brightest suns must one day fade, and in their endings, new worlds are born. A star begins in darkness, deep within vast clouds of gas and dust. Gravity slowly gathers matter together, atoms of hydrogen pulling toward one another over millions of years. At first, there is only cold and silence, a slow tightening spiral of invisible pressure. But as the cloud collapses, it begins to heat from within. The atoms at its center move faster and faster until suddenly they fuse. In that instant, the first light ignites. Hydrogen becomes helium, and energy bursts outward. A star is born. It is as if the universe itself takes a breath. For billions of years, a star remains in this steady balance, gravity pulling inward, fusion pushing outward. The two forces are perfect opposites, keeping the star stable and shining. Our own sun is in this peaceful phase, known as the main sequence. Every second, it converts 4 million tons of matter into pure light and heat, enough to bathe an entire solar system in energy. Yet even this process cannot last forever. When the hydrogen fuel begins to run out, the balance breaks. The star begins to change. As fusion slows in its core, gravity starts to win. The outer layers expand outward, glowing red as the surface cools. The star becomes a red giant, swollen, luminous, and near the end of its life. If it is small, like our sun, it will eventually shed its outer layers into space, forming a glowing shell of gas known as a planetary nebula. The remaining core, hot, dense, and about the size of Earth, becomes a white dwarf, a quiet ember slowly fading over trillions of years. In this way, even in death, a star gives beauty. Its final breath paints the sky with color. Blues, greens, purples, the luminous remnants of its own passing. But for stars much larger than our sun, the ending is far more dramatic. In their cores, the fusion of hydrogen gives way to heavier elements, carbon, oxygen, silicon, even iron. Each new stage burns faster and hotter until, at last, the star can no longer sustain itself. When the core collapses, the outer layers crash inward and rebound in a single, staggering moment. A supernova. For a few weeks, that one dying star can outshine an entire galaxy. Its light can travel millions of light years, crossing the cosmos as a beacon of creation and destruction in the same breath. And within that explosion lies the future, because everything that makes us, the carbon in our cells, the calcium in our bones, the iron in our blood, was forged in such stars. Every atom heavier than hydrogen was born in the furnace of a sun that lived and died long before our world began. When those stars exploded, they scattered their ashes into space. Over time, that dust collected into new stars, new planets, and eventually, us. So when you look at your hands, or breathe, or think, you are quite literally made of starlight. The universe has built itself into consciousness. Some stars, after dying, leave behind even stranger remnants. If the collapsed core is massive enough, gravity crushes it into a neutron star, an object so dense that a single teaspoon of its matter would weigh billions of tons. These stellar corpses spin rapidly, sometimes hundreds of times per second, sweeping beams of radiation through space like cosmic lighthouses. We call them pulsars. Others go further still. If the star is truly enormous, its core collapses beyond any known limit. Gravity becomes infinite, time itself bends, and a black hole is born. A region where nothing, not even light, can escape. Black holes are the universe's silent recyclers. They consume matter, bend the fabric of space, and sometimes, paradoxically, help create new stars by stirring the gas clouds around them. At the heart of nearly every large galaxy, including our own, one of these titans sleeps. A supermassive black hole, millions of times the mass of the Sun. It does not destroy indiscriminately. It anchors, holding the galaxy together through invisible force. The stars orbit it like dancers circling a dark partner, their paths shaped by gravity's unseen hand. It's a humbling thought, that creation and destruction are not opposites, but partners in an endless cycle. Stars are born from clouds of dust, shine through their long, radiant lives, and die scattering the ingredients for the next generation. The universe renews itself endlessly. Every supernova is both an ending and a beginning. Every collapse creates the seeds of something new. The cosmos, in its vast silence, is constantly remaking itself from its own light. To us, a human life feels short, fleeting, fragile. But in the grand story of the stars, even the brightest flame fades eventually. And yet, nothing is ever truly lost. The atoms that make you will one day drift into space again, perhaps to form another world, another sun, another being looking up and wondering the same questions you ask now. In that way, we are all part of a continuous story, not born from chaos, but from the quiet persistence of light. So tonight, when you see a star, don't just think of it as something distant or cold. Think of it as a heartbeat in the universe, pulsing, living, dying, and being reborn. Every point of light above you is a memory of creation, and every breath you take is proof that the stars still live on, within you, around you, and throughout everything that ever was or ever will be. If you look closely at the stars on a clear night, you'll notice something subtle but profound. They are not all the same color. Some shine icy blue, others burn golden or white, while a few glow faintly red. At first glance, it may seem like an illusion, a trick of your eyes adjusting to the dark, but those colors are real. They are the fingerprints of a star's temperature, age, and chemistry, the silent language of starlight itself. In the simplest terms, a star's color reveals its heat. Blue stars are the hottest, their surfaces blazing at more than 25,000 degrees Celsius. They radiate fierce energy, burning their fuel quickly and living short, brilliant lives. A little cooler are the white and yellow stars, like our sun, glowing between 5,000 and 10,000 degrees. And then come the orange and red stars, cooler still, glowing softly at temperatures closer to 3,000 degrees. These crimson suns burn their fuel slowly, patiently, living for hundreds of billions of years, long after brighter stars have gone dark. The spectrum of color across the night sky is like a timeline of cosmic evolution. Each hue tells a story of what the star once was and what it will become. Blue stars, enormous and fierce, live fast and die young, collapsing into supernovae or black holes. Yellow stars, steady and balanced like our sun, live for billions of years before gently fading. And red dwarfs, the most common stars in the universe, outlast them all, glowing faintly but persistently, witnesses to cosmic time itself. In the far future, when most stars have long since burned out, the universe will be lit only by the soft red embers of these ancient suns. But color tells more than just temperature. It reveals composition, what a star is made of. When starlight passes through a prism or a spectroscope, It separates into a rainbow. Across that rainbow are tiny dark lines, missing colors where certain wavelengths of light have been absorbed by elements in the star's atmosphere. Each element leaves a unique pattern, a signature as distinct as a fingerprint. From these spectral lines, astronomers can determine what stars are made of: hydrogen, helium, carbon, iron, and dozens of trace elements forged in the hearts of older stars. Even from millions of light years away, we can read the chemistry of creation. This technique, spectroscopy, changed everything we know about the cosmos. Before it, stars were simply points of light. After it, they became stories, each with a measurable age, temperature, and lineage. We discovered that stars are not separate from us, but part of a continuous cycle of matter. The calcium in your bones, the oxygen in your breath, the gold in your ring, all were once trapped inside the heart of a star. When that star exploded, it scattered those elements into space, where they formed new suns, new planets, and eventually, new life. To look at starlight, then, is to look into the origin of everything that exists. Even subtle shades hold meaning. A blue-white star like Vega is young and massive, its light sharp and clear. Betelgeuse, the red supergiant marking Orion's shoulder, is nearing the end of its life, swelling outward as it prepares for its final transformation. Rigel, another of Orion's jewels, burns with a cold blue flame, 1,000 times more luminous than the sun. Aldebaran, the fiery eye of Taurus, glows orange, signaling stability and age. Each color tells us where a star stands on the grand arc of existence: youth, maturity, decline. The night sky, seen through this lens, becomes a living tapestry of time. And when those lights shimmer, it's not because they flicker themselves, but because Earth's atmosphere bends their light. The turbulence of air causes the starlight to waver, making them seem to twinkle. Planets, being closer and appearing as tiny disks rather than pinpoints, do not twinkle in the same way. That's why astronomers can tell at a glance which objects in the sky are stars and which are worlds. It's a poetic irony. The farther away something is, the more alive it seems to the human eye. To ancient observers, color carried spiritual meaning. The Greeks saw the red of Mars and named it for their god of war. The Chinese mapped blue-white stars as symbols of purity and justice. In Polynesian navigation, the color and brightness of stars told sailors when the seasons were changing. Without instruments or equations, early civilizations learned to read the night sky through its hues, understanding that each light had its own tone in the cosmic symphony. Today, we understand that starlight is more than beauty. It's data. Astronomers use color indexes and spectra to classify stars into 7 main types, labeled O, B, A, F, G, K, and M, from the hottest blue to the coolest red. It's a scale of light, a universal language that tells us where every star fits in the grand design. Even the most distant galaxies can be studied this way. Their combined starlight analyzed to reveal their composition, their age, even their speed through space. By measuring how that light shifts toward the red or blue end of the spectrum, scientists can see whether a galaxy is moving toward us or away, and thus, whether the universe is expanding. So when you see the subtle colors of the stars, you are witnessing the universe's physics in real time. Each hue, each shimmer, is a translation of temperature, chemistry, and motion into something the human eye can perceive. It is nature's most elegant code, written not in words but in wavelengths. The next time you find yourself under a clear sky, take a moment to notice. Look at Sirius, the brightest star in the night, blazing white-blue like a diamond on black velvet. Find Betelgeuse glowing deep red, its vast surface cooling as it nears the end of its life. Watch how Capella shines golden, steady, and calm, a reminder of warmth and balance. You'll begin to see the night not as monochrome, but as a quiet rainbow scattered across eternity. Each color is a language, each photon a message from a distant sun. Some of those messages began their journey before life existed on Earth, traveling across oceans of darkness to reach your eyes tonight. In those colors is everything: the birth of stars, the chemistry of life, the movement of galaxies, and the memory of time. Light is the handwriting of the universe, and the sky above is its endless letter, still being written, still being read in every shade of starlight. When we gaze at the stars, we often notice how they seem to shimmer, flickering gently as if alive. Their light winks in and out, trembling with every breath of the night. That delicate, dancing sparkle has inspired poets for centuries, giving rise to lullabies, myths, and metaphors. But what we see as twinkling is not a property of the stars themselves. It is a gift and a distortion from the air that surrounds us. The light of a star travels through unimaginable distances, across space that is nearly perfect in its emptiness. For thousands, even millions of years, that light moves in silence, unbent and unbroken. Then, in the final fraction of a second before it reaches your eyes, it encounters Earth's atmosphere. There, the journey changes. The starlight must pass through layers of air, each with its own temperature, pressure, and density. Those layers are constantly shifting, rippling like invisible rivers. As the light passes through them, it bends, refracts, and scatters. That bending changes the apparent position of the star ever so slightly, moment by moment. To our eyes, that motion becomes twinkling, a star's gentle pulse in the restless sea of air. It's an illusion, but a beautiful one, a reminder that we view the universe through the lens of our own world. If you could leave Earth and stand above the atmosphere, the stars would no longer flicker. They would burn steady and bright, unblinking against the darkness. Astronauts aboard the International Space Station have described the experience as almost unsettling. To see a sky filled with perfect, motionless light, no shimmer, no dance, only clarity. It is as though the stars, freed from distortion, reveal their true nature. This difference between the trembling earthbound stars and the steady light of space is more than poetic. It's the reason astronomers build observatories on mountain peaks or send telescopes into orbit. The higher you go, the thinner the air becomes, and the less the light bends. That's why the great observatories, Mauna Kea in Hawaii, Paranal in Chile, La Palma in the Canary Islands, all rise above the clouds. Up there, the stars grow sharper, their colors truer, their shapes no longer blurred by turbulence. And beyond all that, floating high above the atmosphere, the Hubble Space Telescope has captured the universe in perfect stillness. No flicker, no interference, just the quiet precision of pure light. But even on Earth, scientists have found ways to tame the twinkle. Using a technique called adaptive optics, modern telescopes can correct for atmospheric distortion in real time. They shoot a beam of laser light into the sky to create an artificial star, a reference point that helps computers measure how the air is bending the light. Then, the telescope's mirror flexes thousands of times per second to cancel out that distortion, restoring the starlight to its original clarity. It is, in essence, a way of momentarily undoing the shimmer of our own world to see the universe as it truly is. And yet, part of the magic of starlight lies in that imperfection. The twinkling of the stars makes them feel alive, as if the sky itself is breathing. In those subtle flickers, we can almost sense the invisible movement of the air. The same currents that shape our weather, carry our voices, and sustain our lives. The trembling of starlight connects heaven and earth, linking the stillness of space to the living, shifting atmosphere that surrounds us. There is a quiet poetry in the fact that we never see the stars exactly as they are. We see them as filtered through our own fragile layer of air, a lens that distorts and transforms. The same light that began its journey before humans existed must pass through the breath of our planet before it becomes sight. Each photon you catch has touched Earth's atmosphere, danced through its turbulence, and carried with it a record of both space and sky. It reminds us that even our act of seeing is an interaction, a collaboration between the cosmos and ourselves. Planets, by contrast, do not twinkle in the same way. Though they too shine with reflected sunlight, they are much closer, appearing as tiny disks rather than distant points. Their light passes through enough of the atmosphere at once to average out the distortions. That's why, when you scan the sky, the steady lights are often planets. Venus, Jupiter, Saturn, while the sparkling ones are distant stars. From this simple difference, ancient sky watchers could tell which lights moved and which did not, long before telescopes existed. For astronomers, the atmosphere's distortion can be a challenge. For poets, it's an inspiration. And for those lying under a dark sky, it's a comfort. Because every flicker you see is a sign of home, proof that you are still beneath a sky with air to breathe, wind to move, and life to live. The stars above may be ancient and remote, but their shimmer belongs entirely to Earth. There's a deeper truth in that too. We are not just observers of the cosmos, we are participants. We look out through a veil that shapes what we see, just as our own experiences shape how we understand it. The stars may not twinkle beyond our atmosphere, but here, within the cradle of air and gravity, they do. And that shimmer tells us that the universe is not separate from us, but reflected through us. So tonight, when you see a star flicker, don't wish it still. Let it move. Let it breathe. That trembling light has crossed eternity to reach your eyes. And in the final moment of its journey, it dances briefly with the living sky. That is not imperfection. That is communion. The cosmos whispering through the atmosphere, its message carried in every pulse of light. Far above the clouds, beyond the reach of weather and air, the stars shine with perfect stillness. Astronauts describe it as almost surreal. A silence so deep, a clarity so sharp that it feels as though the entire universe is holding its breath. Without the veil of atmosphere, there is no twinkle, no shimmer. Only pure light, steady and unwavering, burning against the infinite black. From space, the stars appear sharper than the human mind can easily process. Each one is a fixed, radiant pin of brilliance. There is no haze, no distortion, no color shift. Even faint stars glow with clarity that Earth's surface can never offer. The Milky Way becomes a glowing river of light so vivid that it seems close enough to touch. And between those stars, true blackness, deeper than any night we've ever known. It's in this setting that humanity's greatest eyes, our space telescopes, gaze into the unknown. The Hubble Space Telescope was the first to show us what space really looks like. Launched in 1990, it circles Earth every 97 minutes, drifting above the blur of air. There, in the vacuum of orbit, it captures light that has traveled for billions of years without interruption. Through its mirror, we've seen galaxies spiraling at the edge of the observable universe. We've seen stars forming in luminous clouds and dying in explosions of color. Hubble's images, the pillars of creation, the sombrero galaxy, the deep field, changed not only science, but imagination itself. For the first time, we could see the universe not as theory, but as art, radiant, chaotic, and alive. From Hubble's vantage point, even the smallest details come into focus. Dust lanes twisting through nebulae, shockwaves from stellar explosions, the faint arcs of light bent by gravity itself. These aren't computer renderings or illustrations. They are reality, painted by light that has crossed time itself. Each photon in those images began its journey before humanity's ancestors learned to walk upright. And after billions of years of travel, it found its way into a human-made mirror orbiting a small blue planet, an instrument built by beings made of the same atoms that the stars once forged. It's almost poetic to think that, in photographing the universe, we are capturing our own origins. Hubble's observations proved that galaxies are not static, but moving apart. The universe expanding faster than we once believed. It confirmed that the cosmos is still growing, still changing, still alive. And it revealed that even in what appeared to be emptiness, there is unimaginable abundance. In 1995, astronomers pointed Hubble at a patch of sky so empty it seemed meaningless, a region no larger than a grain of sand held at arm's length. They let it stare there for 10 days, collecting the faintest possible light. When the image was processed, thousands of galaxies appeared, each one containing billions of stars. That picture, known as the Hubble Deep Field, changed human understanding forever. It showed that the universe is not just vast, it is overflowing with light, even where we thought there was none. The emptiest space in the sky is, in truth, full beyond imagining. Looking at those images is like looking into infinity. Every faint dot is a galaxy, every galaxy a swarm of stars, every star a potential cradle of life. When you realize that the field of view covered by the deep field is just a tiny fraction of the sky, 1 part in 24 million, the mind stretches to its limit. If that single patch contains thousands of galaxies, how many fill the rest of the heavens? Hundreds of billions, trillions. Numbers lose meaning. Wonder takes over. The night sky becomes a cathedral of light so immense that every question we've ever asked seems both small and holy. Since Hubble, new eyes have joined the watch. The James Webb Space Telescope, launched in 2021, sees the universe in infrared, light stretched by distance and time. It peers even further back to an era when the first galaxies were just forming, when darkness was being pierced for the first time by starlight. Its golden mirror, vast and delicate, catches light that began its journey over 13 billion years ago. Light that predates our sun, our world, and even our species. Every new image Webb sends home is not just a photograph. It's a message from the dawn of time. And through all this, there is something deeply human about the act of looking outward. No other species builds mirrors to gaze at the beginning of everything. No other consciousness turns curiosity into technology, wonder into precision. Hubble and Webb are, in a sense, our eyes extended, our desire made tangible. We look into the universe not because it belongs to us, but because we belong to it. Each discovery reminds us that we are fragments of that same story, pieces of the cosmos temporarily awake, wondering about itself. When astronauts describe the view of the stars from orbit, they often speak of perspective. Above the air, without atmosphere or horizon, the sky becomes absolute. There is no up, no down, no edge. Earth floats quietly below, glowing with faint blues and greens, a small oasis of warmth in the endless black. And beyond it, silence. A silence that is not empty, but full of light. To see the stars without twinkle is to see them as they truly are, unwavering, constant, eternal in their rhythm. But to see them from Earth, with all our air and wind and life between, is to see them alive, shimmering with the breath of our own planet. Both views are true. One shows us the cosmos as it is, the other as it feels. Together, they complete the picture. The infinite and the intimate, the cold precision of space and the soft heartbeat of home. So as you drift into rest, imagine that stillness, that view from above the sky, where stars hang motionless in perfect clarity. Imagine their light falling over the sleeping Earth, through the air, through your window, finally reaching your eyes. That light has traveled for millions of years to find you, steady in its path, patient in its purpose. And now, for a brief moment, it belongs to you. Let it be your anchor, your calm, your reminder that you are part of a universe vast beyond measure, yet close enough to touch with a single breath. Every star that burns in the night sky lives by one simple truth. Energy must come from within. At their core, stars are not fires burning fuel the way a candle does. They are nuclear furnaces, colossal engines where gravity and atomic forces dance in balance. And that balance, though invisible, is what allows light to exist at all. The story begins in a star's heart. Under unimaginable pressure, hydrogen atoms, the simplest, most abundant element in the universe, are crushed together until they merge, forming helium. This process is called nuclear fusion. It releases vast amounts of energy, converting a tiny fraction of matter directly into light. Einstein's equation, E=mc2, tells us how. Just a small bit of mass multiplied by the speed of light squared equals an enormous burst of energy. It is this transformation that fuels every sunrise, every warm breeze, every photon that has ever reached your eyes. Fusion is a miracle of balance. Gravity wants to collapse the star inward, squeezing it tighter and tighter. But the heat and pressure from fusion push outward, creating an equilibrium that can last for billions of years. This is the quiet heartbeat of the cosmos. Every star in the sky maintaining this perfect tension between collapse and expansion. When the balance holds, a star lives. When it breaks, the story changes forever. In massive stars, that fusion process does not stop at helium. The temperature climbs and new reactions begin. Helium fuses into carbon, then into oxygen, neon, magnesium, silicon, each step building heavier elements in the star's core. But this chain has an end. When fusion begins to produce iron, the process no longer releases energy. It consumes it. The balance collapses, gravity wins, and the star implodes. In an instant, everything reverses. The outer layers rebound outward in a massive explosion, a supernova. For a brief time, that dying star can outshine an entire galaxy, flooding space with light and dust, the seeds of future worlds. Inside the core left behind, the pressure is so intense that protons and electrons merge into neutrons, forming a neutron star, a sphere no wider than a city, but heavier than the sun. Some of these neutron stars spin hundreds of times per second, beaming radiation through space like a cosmic lighthouse. To an observer on Earth, they appear as pulses, rhythmic flashes of light, so regular that they rival the accuracy of atomic clocks. They are the heartbeat of dead stars, still echoing through the darkness. But sometimes gravity pushes even further. If the original star was massive enough, no known force can stop the collapse. The core shrinks beyond its own light, its gravity so strong that space and time curve inward infinitely. This is the birth of a black hole, a point where the rules of physics themselves break down. Nothing escapes, not even light. And yet, black holes do not simply devour, they reshape. They bend the paths of nearby stars, twist light around them, and even power some of the brightest phenomena in the universe. Around an active black hole, matter spirals inward, forming what's called an accretion disk. Friction heats that disk to millions of degrees, causing it to blaze with X-rays and gamma radiation. Jets of particles shoot out from the poles at nearly the speed of light, cutting through the surrounding darkness. Seen from afar, these jets can stretch across galaxies, immense beams of energy that illuminate the void. A black hole, paradoxically, can become one of the brightest objects in existence. And yet, despite all their power, black holes are not monsters lurking in the dark. They are the natural end of a cycle, the silence that follows the song of a star. They hold the history of light within them, not as destruction, but as transformation. Around their edges, space ripples like water, bending time itself. If you could approach one safely, you would see light bent into rings, a halo around the invisible. It is there, in the place where physics bends, that the universe begins to whisper its deepest truths. Everything we know, every planet, every atom in your body, was forged in that stellar cycle of creation and collapse. The iron in your blood was born in the core of a dying sun. The gold in your jewelry was forged in the violent merger of two neutron stars. Calcium, carbon, oxygen, all of it came from nuclear fusion, the same process that keeps the stars alive today. You are, quite literally, made of stardust, held together by the same laws that govern galaxies. When you look at the night sky, you are not an observer of the cosmos. You are the cosmos seeing itself. Even now, somewhere in the universe, a star is collapsing and another is being born. A supernova lights up the dark, scattering new elements through space. Clouds of dust begin to swirl and condense, forming new suns and new worlds. Perhaps, billions of years from now, one of those worlds will give rise to life, creatures who look up and wonder just as we do now. And the cycle will begin again. The stars are not distant objects. They are echoes of our own origin. Their energy flows through everything, through oceans, forests, and thought itself. Fusion built the elements, gravity sculpted them into worlds, and life emerged to remember it all. So when you see a star burning quietly in the sky, know that its light is not just illumination. It is history. It is the soundless music of physics turned into beauty. And that light, that ancient, patient light, is the reason we exist at all. The universe is not a cold machine. It is a living process. It grows, it changes, it learns. From the fusion in a star's core to the spark in a human mind, the same forces are at work. Creation from collision, order from chaos, light from darkness. Every star that has ever lived still burns within you, in every atom that makes you whole. And every thought you have, every heartbeat, every breath, continues that chain of energy, unbroken since the dawn of time. Somewhere, a star's final light is still traveling toward us, crossing millions of years of darkness. When it reaches Earth, it may flicker for only a moment before vanishing forever. But in that instant, we witness a truth both fragile and infinite, that all creation, all existence, is a dance of energy becoming aware of itself, light traveling through eternity, and finding a home for just a moment in your eyes. Among the billions of stars that fill our galaxy, some shine brighter than any other. One of them, known to nearly every stargazer across time, is Sirius, the dog star. It dominates the winter sky, rising with a steady, piercing glow so intense that even in light-polluted cities, it can still be seen. No other star, save the sun, commands such attention. To look upon Sirius is to witness one of the oldest companions of human wonder. The name Sirius comes from the Greek word Sirios, meaning glowing or scorching. Ancient Egyptians watched for its reappearance before dawn each summer, an event that coincided perfectly with the flooding of the Nile, the heartbeat of their civilization. To them, Sirius wasn't just a star, it was a calendar, a messenger of renewal and fertility. They called it Sopdet, goddess of the rising waters, her brilliance marking the turning of the year. In that sense, the dog star was among the first celestial timekeepers, a bridge between heaven's rhythms and Earth's survival. Culturally, Sirius has carried countless meanings. To the Polynesian navigators, it was Turua o Terengi, the guiding flame that marked seasonal voyages. For the Greeks, it was associated with the heat of midsummer. The dog days, when its rising in the morning sky seemed to herald unbearable warmth. In the folklore of North America's First Nations, Sirius was a guardian star, a watchful spirit keeping balance over the sky's great hunting grounds. Even in modern times, the dog star continues to symbolize constancy. the star that always returns, bright, faithful, unchanged. But behind its ancient mystique lies science even more fascinating. Sirius isn't a single star, but a system of two. The primary, Sirius A, is a brilliant white star about twice the size of the Sun and 25 times more luminous. Its companion, Sirius B, is a white dwarf, the collapsed remnant of a once mighty sun. Sirius B was the first white dwarf ever discovered, its existence confirming theories of stellar death and rebirth. Tiny yet dense, it packs the mass of an entire star into a sphere no larger than Earth. A teaspoon of its matter would weigh a ton. Together, these two bodies orbit each other every 50 years, locked in a slow, gravitational dance. Through telescopes, the contrast is striking. One radiant, the other ghostly faint, visible only through precision and patience. In that pairing lies the cycle of existence. Life and death, radiance and memory, energy and silence. Sirius A burns in the prime of its life, while Sirius B lingers as a fossil of light, its fire extinguished, but its presence enduring. Even across such extremes, they remain bound. A binary system reminding us that even the brightest stars do not shine alone. For astronomers, Sirius is a window into the physics of light itself. Its brilliance once puzzled early observers who noted how it seemed to shimmer with shifting colors. Blue, green, red, when seen near the horizon. This wasn't magic, but refraction, as Earth's atmosphere bent its dazzling rays into a kaleidoscope. Those same colors reveal its temperature too, nearly 10,000 degrees at the surface. A furnace of hydrogen blazing pure white. If Sirius replaced our sun, its light would be so intense that it would strip Earth's atmosphere away and boil the oceans into vapor. From afar, though, its glow becomes poetry, bright enough to cast shadows in the darkest desert nights. For millennia, Sirius has fascinated scientists and dreamers alike. In the 19th century, mysterious wobbles in its motion hinted at an unseen companion, proof that Sirius B existed long before it could be observed directly. Today, using modern telescopes and spectroscopy, we can measure its orbit with incredible precision, watching as the two stars tug on each other like dancers joined by gravity's invisible thread. That same pull once shaped the destiny of worlds, and in observing it, we witness the fundamental forces that sculpt the cosmos. But there is also something intimate in our connection to Sirius. When you look at it, you're seeing light that left that system about 8.5 years ago, around the time it takes a human child to grow from birth to curiosity. Each beam you see tonight began its journey before many of your current memories existed. And yet, in that short span of cosmic time, it traveled across trillions of kilometers to meet your eyes. The universe moves slowly, but light moves faithfully, unbroken, unstoppable, patient. In the quiet hours before dawn, Sirius climbs high in the southern sky, glinting with cold brilliance above the sleeping world. It has watched over deserts, oceans, and mountains for longer than any human story can recall. Every civilization that has ever looked up has known it. Every traveler who's lost their way has searched for its glow. It is the same light across generations, threading through the centuries like a silver needle stitching together the fabric of time. Sirius, like all stars, will not shine forever. One day, billions of years from now, it will exhaust its fuel and grow unstable, swelling into a red giant before collapsing into silence like its companion. But by then, its light, the very photons you see tonight, will have traveled through the future, perhaps still wandering across space, perhaps still being seen by other eyes, other worlds. The universe will change, but that journey will continue, because light, once freed, does not look back. There's a reason humanity has always been drawn to the dog star. It's not just its brilliance, or its myths, or its precision in the sky. It's the feeling it gives, the quiet certainty that something out there endures. Every winter, it rises again, unwavering, faithful as ever. And in that return, we find comfort, a reminder that amid all change, some lights remain constant, if only to show us that we too belong to the rhythm of the stars. So when you see Sirius tonight, low and shimmering at first, then rising to burn steady and pure, take a breath. That light has crossed 8 years of space to reach you. It carries within it the memory of fusion, gravity, and time. It is both ancient and immediate, both distant and here. A message written in fire traveling through silence, whispering across the cold expanse that even the brightest stars fade, but their light, once released, lasts forever. There are few sights in the night sky more enchanting than the Pleiades, a tiny cluster of stars that glimmer like a handful of diamonds scattered across black velvet. Known as the Seven Sisters, the Pleiades have guided myth, navigation, and imagination for as long as humans have looked upward. Even through the naked eye, they stand out. A small, delicate grouping in the constellation Taurus, glowing with a faint, silvery light. To see them on a clear night is to feel as though you are gazing at something both intimate and infinite, fragile, yet eternal. In reality, the Pleiades are not 7 stars, but hundreds, a true star cluster bound by gravity. Most are young, no more than 100 million years old, still glowing with the blue-white brilliance of youth. To astronomers, they are a laboratory of creation, a glimpse into how stars form, grow, and drift apart. Through binoculars, their shimmer blossoms into dozens of points, each a newborn sun burning fiercely in the prime of its life. Photographs reveal wisps of surrounding dust, remnants of the very cloud from which these stars were born. That misty glow reflects their light like fog around a candle, turning the cluster into one of the most beautiful objects in the sky. Across cultures and continents, the Pleiades have carried countless names and stories. The Greeks saw them as the 7 daughters of the Titan Atlas and the sea nymph Pleione, pursued by the hunter Orion, until the gods placed them among the stars for protection. In Japan, they are called Subaru, meaning to unite, their clustered forms symbolizing harmony, a name now immortalized in the car company's logo. 6 stars shining as one. To the Maori of New Zealand, the cluster is Matariki, marking the beginning of the new year, a time of remembrance and renewal. In ancient China, it was the hairy head of the White Tiger constellation, an omen of harvest. And among Native American tribes, they were fire girls, or children who climbed into the sky to escape danger, forever glowing above their people. Every culture found meaning in those 7 lights, and perhaps that's because their appearance feels deeply human. A small family of stars, close and connected, shining together in the vastness. Astronomically, the Pleiades are a special kind of cluster known as an open cluster, unlike the tightly packed globular clusters that orbit the outer halo of the Milky Way. Open clusters form within the galactic disk, groups of siblings born from the same cloud of gas and dust. Over millions of years, the gravitational pull of the galaxy will slowly scatter them, sending each star drifting into its own solitary orbit. The Pleiades, then, are a family caught in a fleeting moment, a snapshot of togetherness before time pulls them apart. In cosmic terms, it is a brief embrace that will last only a few 100 million years more before the sisters disperse into the wider Milky Way. Their brightness and beauty have made them navigational landmarks since the earliest days of exploration. Sailors across the Pacific watched for the Pleiades to rise and set, using them to chart seasons and directions. In Greece and Rome, their first appearance before dawn signaled the start of the sailing season. Their disappearance in autumn marked its end. Even in modern times, when ships no longer rely on the stars, Their rising in the early morning sky still carries an echo of that ancient rhythm, the pulse of time measured in starlight. Scientifically, the Pleiades also offer a clue to one of astronomy's most fundamental questions. How far away are the stars? For centuries, astronomers struggled to measure their true distance, debating between models that place them anywhere from a few dozen to several hundred light-years away. Modern instruments have settled the number at around 444 light-years, close enough for their light to feel immediate, yet distant enough that what we see tonight began its journey around the time humans first began to record history. Each glint of blue light from the Pleiades is a century-long echo, a time capsule of youth preserved in motion. And while their stars burn bright, they also whisper of impermanence. Like all clusters, the Pleiades are destined to fade. Their stars will slowly drift apart, scattered by gravitational tides and passing clouds of gas. One by one, they will disappear into the background of the galaxy, their family ties broken by the sheer vastness of time. One day, perhaps hundreds of millions of years from now, no one in the universe will look up and see the seven sisters as we do today. Their beauty will survive only in memory, in the light still traveling outward, endlessly, through space. That transience gives the Pleiades their quiet, emotional power. They are not eternal, but luminous in their impermanence. A reminder that all things, even the stars, are bound by time's slow hand. The cluster is young by cosmic standards, but already unraveling. And yet, in this moment, their closeness creates a harmony rarely seen in the heavens. To look at them now is to witness connection itself. Gravity made visible, light made familial. For ancient storytellers, that closeness carried meaning. The Greeks said that one of the sisters, Merope, dimmed her light out of shame for marrying a mortal, explaining why only 6 stars are easily visible. Others believed she simply wandered too far from her sisters, lost in the sea of stars. Astronomers, however, know that faintness comes from physics, not myth, the human eye's limit of sensitivity. But perhaps both truths can coexist, the science of light and the poetry of loss. Because when we gaze upon the Pleiades, we do not just see stars, we see the pattern of family, of connection, of separation, the story of life itself written across the night. Every time you spot them rising in the eastern sky, remember that their light has crossed 4 centuries to reach you. Remember, too, that what you're seeing is a moment that will one day vanish. Not in your lifetime, not in any lifetime, but eventually, inevitably. That is what makes them so beautiful. They remind us that even in the cosmic scale, beauty often lies not in permanence, but in presence, in the fact that we were here to see them, now, together. So if you find yourself beneath a clear winter sky, look for that tiny cluster shimmering near Orion's shoulder. Pause a moment. Let your eyes adjust. You might count 6 stars, or 7, or more. It doesn't matter. What matters is the feeling they awaken, the quiet knowledge that even across the vastness of space, there are still things that stay together, if only for a while. And that perhaps, somewhere far away, another being is looking back at them too, tracing the same constellation, feeling the same wonder under the same ancient light. Beneath the familiar belt of Orion, 3 bright stars aligned in perfect symmetry, lies a secret most stargazers overlook. A faint, misty patch of light that glows softly to the human eye. This is the Orion Nebula, one of the most breathtaking wonders in the entire night sky, and one of the closest stellar nurseries to Earth. It is a cradle of creation, a vast cloud of gas and dust where new stars are being born right now, sculpted by light, gravity, and time. To the unaided eye, the nebula appears as a subtle blur, easily mistaken for a smudge on the lens of the heavens. But through binoculars, it blooms into a delicate swirl of radiance. And when seen through a telescope, it transforms completely. Luminous tendrils of pink, green, and violet weave together like cosmic smoke, forming a glowing curtain of light. It is here, within this nebula, that thousands of newborn suns are kindling, their heat illuminating the cloud that birthed them. Each one is a spark of potential, surrounded by disks of dust that may one day form planets, moons, and worlds. The Orion Nebula lies about 1,300 light-years from Earth, close enough that its details can be studied in remarkable clarity. It spans more than 20 light-years across, large enough to hold tens of thousands of solar systems. At its heart burns a cluster of hot, massive stars known as the trapezium, whose intense ultraviolet radiation causes the surrounding hydrogen gas to glow. This is what makes the nebula visible, a cosmic canvas painted not by reflection, but by ionization, where light itself becomes the brush. To astronomers, the Orion Nebula is a living laboratory, a place where the process of creation unfolds before our eyes. Within its folds, we can watch the earliest moments of stellar evolution. Clouds collapsing, matter heating, fusion igniting. Even planets are taking shape here, hidden in cocoons of dust. It is a glimpse into the same forces that once formed our own sun more than 4.5 billion years ago. To study Orion is, in many ways, to look backward through time, to witness our own beginnings replayed in the distant dark. Long before telescopes revealed its structure, ancient civilizations saw meaning in Orion's shape. The Egyptians associated the constellation with Osiris, god of the afterlife, believing the souls of kings ascended to the stars through its belt. In Greek mythology, Orion was the great hunter, immortalized by Zeus in the sky. To the Maori, it was the figure of Totoro, a sacred marker for planting and navigation. For millennia, these myths carried a truth that science would later confirm. Orion is a place of transformation, where life and death, creation and memory, intertwine across time. The nebula's light that reaches us tonight began its journey over a millennium ago. Before the rise of medieval Europe, before paper reached the West, before telescopes were even imagined, that glow, faint but unbroken, has been traveling toward us since long before we were capable of understanding it. To look at Orion is to look at a message from the past, not written in words but in photons, telling the story of stars being born. And yet, for all its grandeur, the Orion Nebula is not unique. All across the galaxy, vast clouds like it drift in silence, gathering and collapsing into new suns. These stellar nurseries are where the universe renews itself, recycling the ashes of old stars into the building blocks of the next generation. It is the same cycle that forged the carbon in our cells and the oxygen we breathe. Life, in the most profound sense, begins in places like Orion, within the cold, dark clouds of interstellar space. The light of the Orion Nebula glows because of a process called emission. When ultraviolet radiation from young, massive stars strikes the hydrogen gas surrounding them, it excites the atoms, causing them to emit light of their own. The result is a luminous glow that spans the visible spectrum. Crimson from hydrogen, green from oxygen, violet from helium. Each hue tells a story about the chemical composition of the nebula and the energy of its stars. Together, they form a radiant tapestry that has inspired astronomers and artists alike for centuries. There are other nebulae too, each with their own colors and mysteries. Some, like the Eagle Nebula, are sculpted into towering columns, the famous pillars of creation, where stars emerge from dense knots of gas. Others, like the Lagoon Nebula or the Carina Nebula, stretch for hundreds of light years, bursting with turbulence and energy. And beyond them lie reflection nebulae, which do not shine on their own but reflect the light of nearby stars, glowing blue like cosmic mirrors. In each one, the same story unfolds. Light born from gravity's embrace, darkness giving birth to brilliance. Nebulae are not static. They are in constant motion, expanding, fragmenting, reshaping. The Orion Nebula itself is only a temporary phenomenon in cosmic terms. Eventually, its gases will disperse, blown apart by stellar winds and radiation. What remains will be the cluster of stars it created, a newborn family drifting away into the Milky Way. The beauty we see now is transient, a fleeting moment in the vast evolution of matter and light. And yet, that impermanence makes it all the more profound. To witness the Orion Nebula is to witness creation in progress, the birth of stars that will shine for billions of years after we are gone. Those future suns may one day warm planets, oceans, and perhaps life itself. When you gaze upon that faint glow, you are looking at tomorrow in the making. It's humbling to think that everything we know, every world, every creature, every element, began in places like this. The same forces shaping Orion shaped us. The dust that now gathers into new stars once drifted through the same galaxy that holds our sun. We are connected to these clouds not metaphorically, but physically. Their chemistry is our chemistry, their light, our inheritance. So the next time you step outside and find Orion in the sky, the belt, the sword, the soft gleam of the nebula beneath, pause. You are witnessing a stellar nursery, a forge of worlds, a living sculpture of time and matter. You are seeing the process that once gave birth to your own world, billions of years before human eyes ever looked upward. The Orion Nebula is not just a place in space. It is the memory of creation itself, a reminder that even in the darkest clouds, light is always being born. In the great expanse of the cosmos, not all nebulae shine with their own light. Some, instead, act as mirrors. Vast clouds of dust that catch the radiance of nearby stars and scatter it softly across the darkness. These are known as reflection nebulae, and they glow not through heat or fusion, but through grace, by reflecting the light of others. They are the quiet whispers of the night sky, faint, ethereal, and filled with subtle beauty. Unlike the fiery glow of emission nebulae, which blaze with color from energized gas, reflection nebulae shimmer with borrowed brilliance. Their light is gentler, bluer, more subdued, the result of dust scattering starlight the same way Earth's atmosphere scatters sunlight, turning our skies blue. Inside these cosmic mirrors, tiny grains of carbon and silicate, smaller than smoke, drift in delicate balance. When starlight touches them, it diffuses into soft halos, painting the dark with cool luminescence. It's one of the simplest yet most poetic processes in the universe. Light meeting dust and becoming beauty. One of the most famous examples surrounds the Pleiades cluster, where brilliant blue stars illuminate thin veils of dust that still linger from their birth cloud. Through a telescope, this nebula appears as a silvery mist wrapping the cluster, a celestial echo of the light that first ignited the sisters. The same dust that once helped form those stars now reflects their glow, preserving the connection between past and present. In a way, the Pleiades Reflection Nebula is a cosmic photograph, the light of youth captured in the gentle haze of memory. Elsewhere in the sky, reflection nebulae take many shapes. The Witch Head Nebula near the star Rigel in Orion resembles a spectral face against the void, its faint blue light shining through a curtain of cosmic smoke. The Iris Nebula, a delicate bloom in the constellation Cepheus, glows like a frozen flower of light. And the Blue Horsehead Nebula, in Scorpius, drifts like a phantom steed galloping through space, its mane made of dust and light intertwined. Each of these nebulae tells the same story, not of stars blazing into life, but of the quiet aftermath when the surrounding dust continues to whisper their names across the universe. To astronomers, reflection nebulae are invaluable. They reveal the composition of interstellar dust and the scattering properties of light, details that help decode how galaxies evolve and recycle their material. But beyond science, they remind us of something deeper, that illumination does not always come from within. Sometimes it comes from what we reflect, from the light that passes through us, touches us, and leaves us changed. The blue hue of these nebulae is more than aesthetic. It is physical truth. Shorter wavelengths of light, blue and violet, scatter more efficiently than red, just as sunlight scatters through our sky during the day. That is why most reflection nebulae glow in shades of azure, their soft tones hinting at the delicate structure of cosmic dust. In some cases, the light comes from a single star. In others, from clusters whose combined radiance bathes their surroundings. Each photon that leaves a star may travel for centuries before encountering a speck of dust, bouncing once, twice, or 1,000 times before reaching our eyes. Every faint shimmer we see is the end of a long, wandering journey of light. The interplay between emission and reflection nebulae often creates breathtaking contrasts. In regions like the Trifid Nebula, glowing red hydrogen clouds mingle with blue reflection regions, forming a natural masterpiece of color and complexity. It's as if the cosmos itself were painting, using gas for brilliance, dust for texture, and gravity for form. Through this delicate choreography, the universe transforms physics into art, turning the cold mechanics of atoms into something sublime and emotional. Even in their silence, reflection nebulae are active participants in creation. Dust grains inside them serve as the seeds for new stars and planets. Within those grains, molecules of water, carbon, and organic compounds can form, the building blocks of life. Eventually, these clouds collapse, fuse, and ignite, beginning the cycle anew. A reflection nebula may one day become a nursery again, proving that even in stillness, creation never truly stops. For poets and dreamers, these nebulae are metaphors come alive. They are the introverts of the cosmos, quiet, subtle, radiant through reflection rather than flame. They remind us that brilliance can come not only from burning brightly, but also from carrying the light of others with grace. The night sky is full of such contrasts, stars that blaze and fade, clouds that glow and vanish, beauty that endures in both action and echo. Reflection. Nebulae teach us that light's greatest gift is not dominance, but sharing. Imagine standing beneath a clear, dark sky and peering into the depths of Orion or Taurus. Through binoculars, a faint mist appears, a wisp of blue, delicate and ghost-like. You are looking not at light itself, but at light's memory, preserved in dust older than the earth. That glow has traveled for hundreds of years to find you, bouncing through invisible grains smaller than a hair, carrying within it the story of the star it left behind. Each reflection nebula is a letter written in light, a reminder that beauty can exist quietly, softly, without need for fire. And perhaps, in that lesson, we find something of ourselves. Human lives, too, are reflections. Of moments shared, of kindness passed on, of love and thought and learning that echo long after their source is gone. Like the nebulae, we glow not only by our own energy, but by what we receive and return. Light touches us, we scatter it, and the pattern of that scattering becomes our story. So when you see a faint blue shimmer in the night, a ghost of starlight drifting between constellations, remember, you are witnessing one of the gentlest miracles in existence, a place where light refuses to die, choosing instead to linger, to dance softly in the dust. The cosmos, in that moment, is whispering a truth older than time, that all illumination, no matter how faint, is a form of connection, and that even after the brightest stars fade, their light continues to live on, reflected endlessly, beautifully in the dark. When you gaze upon the stars, it's tempting to imagine each one as a lonely beacon, a solitary sun adrift in the darkness. But the truth is more intricate and far more beautiful. Many stars are not alone. They exist in pairs, trios, even clusters, bound together by gravity in endless celestial dances. These are the binary and multiple star systems, where companionship is written into the very fabric of the cosmos. In a binary system, two stars orbit a shared center of gravity. Sometimes the partners are nearly equal, twin suns circling one another in perfect balance, their combined light blending into one. Other times the pairing is uneven, a massive star blazing fiercely while its smaller companion traces wide, graceful loops around it. To the human eye, they often appear as a single point of light, their union too tight to separate. But through a telescope, their true nature is revealed. A slow, perpetual dance that can last billions of years. Our sun, solitary and stable, is actually something of an exception. Astronomers estimate that more than half of all stars in the Milky Way belong to binary or multiple systems. It seems the universe prefers company. From the smallest red dwarfs to the largest blue giants, stars are born together in clusters, and many remain gravitationally bound for life. Even when they drift apart, their shared origins can be traced in their motion, silent siblings scattered through the galaxy. The dynamics of these star pairs are mesmerizing. In close binaries, the stars orbit so near that their atmospheres touch, exchanging gas and energy in a delicate equilibrium. One may draw material from the other, forming swirling disks of plasma that glow with fierce intensity. Sometimes the smaller star becomes a parasite of sorts, feeding on its larger partner's outer layers. In extreme cases, the two merge completely, erupting as brilliant novae, a sudden outburst that can light up the sky for weeks before fading again into calm. Other binaries are wide systems, separated by vast distances but still tethered by the invisible thread of gravity. They move around one another in slow motion, completing a single orbit in centuries or even millennia. To an observer, they appear as eternal companions, always apart, yet always connected. If you could watch their paths sped up, it would look like a dance of patience, a waltz across eons, graceful and infinite. And there are more complex systems still, triple or quadruple star systems, where 3 or 4 suns weave through space together. In a triple system, 2 may form a close binary, while a third circles farther out, creating layers of motion like the gears of a cosmic clock. In a quadruple, pairs orbit pairs, the gravitational choreography even more elaborate. To any planets caught within such systems, the skies would be breathtaking. Multiple suns rising and setting, overlapping shadows, days bathed in gold and blue light. Imagine standing on such a world, watching 3 sunsets at once, each star painting the horizon with a different hue. What would life feel like beneath that rhythm of light? These systems are not rare curiosities. They may, in fact, be the norm across the galaxy. And their existence challenges us to rethink what we consider normal. Our single sun gives us stability, predictable seasons, gentle tides, the steady heartbeat of life. But elsewhere, in those double and triple skies, chaos and beauty coexist in ways that defy imagination. There, the idea of a day or year has no fixed meaning. Every orbit, every shadow, every dawn is unique. Astronomers study binary stars for more than their beauty. They are keys to unlocking the secrets of mass, gravity, and evolution. By observing how 2 stars move around each other, scientists can measure their masses with precision, something impossible to do with single stars alone. Some binaries eclipse one another from our point of view, causing their combined brightness to dip rhythmically. These eclipsing binaries are natural laboratories, revealing not just mass but radius, temperature, and even atmospheric composition. Each flicker of light is a coded message, carrying data across space. Binary stars also play dramatic roles in the life and death of the cosmos. When one star in a pair reaches the end of its life, it can transfer matter to its companion, igniting explosive events. A white dwarf feeding on a nearby red giant can detonate in a Type Ia supernova, briefly outshining an entire galaxy. These supernovae act as cosmic yardsticks, helping astronomers measure the expansion of the universe itself. In this way, the quiet relationship between two stars becomes a tool for understanding the fate of all existence. And then there are systems that defy belief, where one of the partners is not a star at all, but a neutron star or a black hole. When a living star orbits such an object, their interaction creates some of the most extreme environments known to science. Matter spirals inward, heated to millions of degrees, emitting X-rays that we can detect from Earth. These systems are both deadly and magnificent, showing how gravity, at its most powerful, becomes a sculptor of light. Yet for all their complexity, there's something profoundly moving about the idea of two stars bound together. They are constant reminders that even in the vast emptiness of space, connection exists. That gravity, invisible, silent, patient, can hold two blazing hearts together for billions of years. Sometimes they orbit peacefully, sometimes they devour each other. But through every change, they remain entwined, proving that even in the universe's coldest corners, there is companionship. Perhaps that is why we find something human in the way stars move. Their patterns mirror our own relationships. Attraction, distance, return, the balance of independence and unity. They show us that light does not exist in isolation. It thrives in interaction. In every binary system, the lesson is the same. Existence is not about being alone in the dark, but about how we move through it, together. Good night, and see you in the next video.